Alright.
Morning, all Wednesday, September 1, 2021. New day today.
Get him!
Chicken ranch pasta, corn dog, combo sub and chef salad, main line, pork and grill, cheeseburger, and box roasted. The Wednesday today, Miller. Will be a student council meeting for all new student council members. That'll be on Friday over lunch in Mr. Gaines' room. All student council members need to attend. All students welcome to Friday Forum. This Friday during lunch in the light room. Week's topic, managing school and the COVID era. The SAT exam is 2 years. December 8th. Next Wednesday, your registration deadline for that. National Merit Scholarship. If you want one of those, you have to take that test. Test will begin block 1 and 2 on October 13th. Stop in the counseling office for more information. First meeting of the Robotics Club. We held lunch in the library tomorrow, Thursday, September 2nd. Robotics, if you're interested in robotics, all interested students, please attend. Please stand for the pledge. To the flag.
Of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All have a great day.
Remember, it's open to all resources. Go back and look through your notes, book, homework. School should not be a I gotcha endeavor. It should be, when fully supported, what can you do? Move your bag to the other side. I'm a klutz and I'm going to trip over it. Remember, especially for that second one, simplify. Not give me decimal value of. Simplify. Yes, sir.
Stuck. There's no way to simplify that.
Can they both be written in the same base? Because we had several examples. Oh, yeah, they can.
Nothing that's cubed root doesn't to 125.
Same base. Can both 625 and 125 be written as a power of the same number? Correct path, keep going. Oh, I don't know. Oh, well, I do know, but I'm not going to tell you. You are on the right path. Trust your instincts, young Jedi. Got that one from Mrs. Bowerly. Remember her?
Oh yeah. Whoa.
Yeah. Yeah. Last time I went over to their house just for like a day-long geekathon, she kept coming up to me like a cat brings you a dead mouse or something. She kept coming up to me and be like, "Look, look, it's cool." Kept bringing me fidgets. It was cool. And then I ruined one of her favorite fidgets forever by making an inappropriate reference with it. She said, "Now I can't unsee that. Take this away from me." I'm going to be 12 for the rest of my life.
Bless you.
Power of Christ compels you. Okay, what I see is we know how to work with the radicals on the first one. Some of us are really struggling with the second one because maybe we don't know our squares through 20, cubes through 10, fourths through 5 off the top of our head. I'll tell you 625 and 125 can both be written as powers of the same base. Yo!
I can't take anything out of that one.
But you can write both 625 and 125 as the same base.
How? I can't.
For example, 27 and 81 could both be written as 3 to the third and 3 to the fourth, respectively.
See, that is what I was supposed to do. This feels
Yes.
like a ridiculous clown number.
Oh, it is a ridiculous clown number. It's a radical. It is literally irrational. It is a clown.
But I'm glad
You're right.
it's the correct one.
Yes.
Okay, so this is the. Do simplify it further.
How'd they get out of radical land?
I don't know.
How about this? Hint, hint. Example 3, part A. Hey.
I can simplify that down to there, right?
You can.
Is it needed?
Well, it does have the word simplify up there, so whatever you're getting, I want it in its simplest form.
Yay.
Look, I did it right.
Okay, this is going way too long. I'm going to give you another minute. Okay. Round one. Why aren't you here? Oh, there you are. No, I said over here. Listen to what I tell you. Sixth root of. If I have no idea what something to the sixth is that goes into 128, you can always break that down old school. You remember prime factor trees? Well, I know that that's 2 times something because it's even, 64. Okay, that's 8 and 8. Those are 4 and 2. Those are 2 and 2. All the way down, and you get this is 2 to the 7th. So if I rewrite that as 64 by 2, 64 is 2 to the 6th. Okay. And you can write it either way, too. So maybe I do 2 to the 6 times 2 is 128. I'll turn this into y plus 2 to the 24th, because again, I want it to be divisible by 6, times y plus 2 squared. So 6 rush the guard, only 1 gets out. 4 groups of 6 rush the guard, only 1 gets out. Yo.
Wouldn't it be 5 plus 2 to the 4th because there was 28? Not 26.
What?
You put
Oh! Oops. Yeah, words. There you go. And then what's outside? Yes. I'm getting there. Do I need absolute value or not?
no.
Because it's even. And then inside I still have 6 root of 2 y plus 2 to the 4th. Okay. 625 can be written as 5 to what power? Okay. So this is 5 to the 4th, third root. 125 can be written as 5 to the 3rd. And our rational exponents from yesterday says this can be written as 5 to the 4/3, 5 to the 3/4. Not you, you. Which, by 4 can be written as 16/12. By 3 can be written as 9/12. And exponent over exponent, I subtract the exponents and get 7/12. So this is 5 to the 7/12, which is the 12th root of 5 to the 7th, which is so 525, 3125, 15,625, 76, 77 something. I don't know. I lose it after that one. Yep.
So for that problem, I just simplified the top to 5 root 3 inside 5.
Yeah.
5. And then I multiplied both by 5 root 4. So I could simplify the bottom to 5.
Okay.
Just cross out both 5s, and what I was left with was root 5. Like 4, 5, the 4th root, times 5 to the 3rd root.
So not fully simplified.
But then I simplified it to 5 to the 7th power to the 12th root.
But you can't just combine indices like that. Because you won't have common denominators for your rational exponents. You can't just smash the indices together and say it's now this.
Well, if you multiply, then you add the things, right? Yeah. I did a lot of work for like the same answer. I don't know how, but I got 5 and 7/12.
If you try to simplify as is right now, that's as far as you can get. Right?
Right. So I multiplied both 5 root 4.
5 root of 4?
So 5 inside of that. I don't know how to say it.
4th root of 5?
4th root of 5.
Okay. Because right now I have a 4th root of 5 to the 3rd. I need one more 5 to get out of radical jail. Okay, legal so far.
Okay. And then the bottom is simplified to just 5.
Correct. Which cancels out with the 5 on the numerator. Correct.
So you're just left with the 3rd root of 5 and the 4th root of 5.
Correct.
Simplified to 5 to the 1/3 power and 5 to the 1/4 power. You multiply those together.
Okay, your words weren't saying that. They were just spewing out numbers. Yes, you are correct.
Okay.
Okay.
Thank you.
That is a different route, yes.
I don't know how to speak math, so.
English with math, damn you, Satan.
What, man?
Okay, yes, either one of those. So what we're gonna do is break it up correctly, simplify it correctly. Either one of these, break it up correctly, simplify it correctly, and then you might see this as a common theme. One is a floater for, oops, I did the dumb. I said 4/3 is 12/16 instead of 16/12. I accidentally wrote a y plus 2 to the second instead of y plus 2 to the fourth. You did the little goof, okay? So 2 each and then a floater for the itty bitty little oof. Yep.
Do you have to put absolute value around y plus 2 to the fourth?
Do I? It's an even power that came out. So no matter what y is, that thing is going to end up positive. So no, I don't.
Would I get points taken away if I did put absolute value?
Because we explicitly talked about that yesterday? Yes. 1 off. That would be your 1 floater goof.
Okay.
All right. You go away.
4 out of 5, so.
Yep, yep. Talk to me, gooses. I don't know what the last question was. 32. Same as if you have a question and you text me. And if you just ask, how do I do 32? Like, y'all, I'm nowhere near a book. I don't know. I don't know what that is. Okay. So 4th root of 96, a to the 8th, b to the 6th, c to the 20th. I need to know a perfect fourth that goes into 96. Now, if I don't know off the top of my head what that is, you can always go old school and say, well, I know it's even, at the very least. Well, I know that one, 6 and 8, I know that's 2 and 3, 4 and 2, 2 and 2. So if I have a prime factorization of 2, 2, 3, 2, 2, 2, I hate you. Then, oh, there's more 2s. Whatever. I see 1, 2, 3, 4, 5 2s and a 3. If I can write this as 2 to the 5th by 3 instead of 96, you see how now you could break out a something to the 4th. Now I can call this the 4th root of 2 to the 4th. I'll have a 2 and a 3 left over, so 6, or you can call it 16 by 6. By a to the 8th, by b to the, I'm going to call it 4th and 2nd. It's still altogether 6 b's, but now I have something divisible by 4. I want things divisible by 4, at least in the exponent. And then c to the 20th. Now, we got the 4th root of something to the 4th is that something. The 4th root of something to the 8th is that something squared. The 4th root of something to the 4th is that something. The 4th root of something to the 20th is that something to the 5th. Now, oh, Jesus. Absolute value or not?
Yes.
On what? The B and the C, because they're both odd powers. So that will be my final answer. We'll have 2a squared absolute value of bc to the 5th. 4th root of, there's still a 6b squared left in radical jail. Okay, you keep breaking it up and look for groups of 4.
That's what I got, and like I did it it that way, and then I wanted to check it, and I went on the solutions, and it had like a way more complicated thing. That's why I wanted to check it.
Were the solutions dumb? Okay. You're old enough now, we can have this awkward discussion. When two people really like each other. Wait, not that one. When you switch from one textbook publisher to another, you have to expect differences. I might not be what you specifically found, but I don't know if any of you ever used the solutions for the Pearson series for Algebra 1, Geometry, Algebra 2. Okay. Bummer for everyone who did Algebra 2 last year. You're probably kicking yourself now to know that the solutions for everything in Algebra 2 were on my website the whole time. The Pearson series, its solutions are pretty solid. What usually happens with a textbook publisher is it's a bunch of college professors and former college professors and educational professionals that now work for the company. They get together, they make the problem sets, they make the scope and sequence of it, they talk about how to write the actual parts of it, but then when it comes time for the solutions, they farm that out to their grad students who have to do what they say. Pearson did a good job with that. McGraw-Hill, on the other hand, I'm pretty sure their grad students were hungover the entire time. You are going to find multiple errors in every section's solutions. I try to avoid those problems. Just over the years, kids said, no, that's not even close to what's in the solutions. I just stopped assigning that number. But be aware, if you try a problem, you're pretty sure you did it right, you look at it, and they're not even using the same variable, yeah, someone had a good weekend and then came to class and started working for Dr. Brown, and it didn't work out. Okay? So if you're ever not sure about the solutions themselves, you can just take a picture of the solutions and send that to me and like, did they do this right? Or is this for the same problem? And then I'll double check it. Okay? But yeah, this book and its solution manual is not the best. Most of the time it's okay, but going from like 0.3% errors down to like 1.5% errors, it's enough to notice. I just want you to be aware of that. Besides 32. Words. The value of a car depreciates or declines over the course of life. True. Unless you have a global pandemic and a bunch of data miners who are stealing all the electronics, and now y'all tried to look at the prices of a used car in the last like 6 months. Nationwide, they've gone up like 35%. There's a bunch of cars, like hundreds of thousands of cars sitting in a parking lot outside of the Toyota plant in Texas. Just sitting there, brand new cars that don't run because they're all missing just one chip. Because all of the data miners that are making Bitcoin and stuff, they're all hogging that stuff up. No joke. The new value V and the original value V are related by formula. R is the rate of depreciation and is number of years. Suppose current value of the car is 12,000. Replace V. What would the value of the car be after 18 months? And it did, it said N is number of years. So how do I, okay, call it 3/2. I like that you went for fraction town because that's a little bit easier dealing with radicals because now it's a rational exponent. And annual depreciation rate of 20%. So it's going to go down 20%. Yeah. Y'all remember this one? Probably from back in middle school. Decimal to percent or percent to decimal, you move it that way, 2 places. So it's 20%, so move the decimal 2 places to the left. Yeah. Jam it in, and it just says what is the value, so you don't even have to like solve anything. You just jam it in your calculator. Okay. Now, if it was the other way around, like say the 12,000 was here and they wanted to know what the original was, okay, now I have to solve that equation by taking, I have to divide by this whole honking thing. That's it. Yep. Others? Speak now or forever hold your pieces. Cool. Then we left off with substitution. Basic elimination. Show me you remember how to do it 2 variable before we go to 3. We're talking chapter 6, algebra half. Show me you remember the ancient magic. Do not cite the ancient magic to me, witch. I was there when it was written.
Wait, is this on the note sheet? Is this wait?
Notes. Yo! That's not intentional. I just have horrible short-term memory. Multiple reasons. I was hitting the head a lot in high school. Football, a couple of car wrecks. Yeah. Well, one wasn't actually a wreck. It was just like the windshield is right here. It was a little Cushman, kind of like the 1970s Gator. I kind of put my head through it. Yeah. So, what was it? I gotta think. No, the boss finally fixed the brakes. What do we have? Flipped the car sophomore year. Fractured wrist, dislocated shoulder, concussion. Junior year football, laid out cold in practice. Following summer, senior year, head into the windshield and hitting the head with a railroad tie. Old playground equipment used to be made out of like railroad ties and stuff. We had a whole pile of it. We had to disassemble all the equipment because it didn't meet OSHA standards anymore. Me and the other guy I was working with, we both got chainsaws and we are cutting out all the metal chunks. He's further up the pile than me. That was not a safe work environment. Hindsight is 20/20. And a like 4-foot section of railroad tie came tumbling down the pile and got me straight in the noggin. I still have the dent right here. Yeah. And then knocked out again senior year in football, like to the point of forcible retirement. I was having seizures and memory loss and occasionally losing my sight, and yeah, it was bad. Combine that with object permanence. Anyone here familiar with the concept of object permanence? If I no longer see it, it does not exist. If it's not right in front of me, I will forget that this is a thing. Like 2 minutes later. Very common among autistics and ADHD. So, I did not intentionally forget those. You will have to remind me all year long. Elimination. The idea behind it is, let's say, this is a teeter-totter, it is a balance. Everything's perfect. Balanced, great. And then I come to this table. and everything is perfectly balanced. I don't know, maybe you got an adamantium skeleton or something, okay? I should now be able to take you and put you on this teeter-totter, and it's still balanced, right? Balance with balance, balance with balance, all together, still balanced. So, if I just add together this side and that side, it should still be balanced, right? Well, right now that's not going to accomplish anything. I'm just going to have another equation that's got x's and y's in it. But instead, what if I manipulated the equations with one of my rules of systems of equations that says I can multiply any equation by a thing? I can take everyone on this teeter-totter and I can double their weight. Okay, put you all on one of the like iron moons of Jupiter or something, so you all just increase gravity. It's still balanced, right? Because you're all still the same mass. I can take any equation and multiply it by a thing so that it is still balanced, just looks different. I can take any equation and multiply it by a thing. It's still balanced. It just looks different. Because now when I add those two sides together, I eliminate. Okay. Or you can take one equation minus the other and all that kind of. The reason that I always add equations together is because if you're subtracting an equation, you have to remember to put that negative on each term as you're working. It's more steps to remember, and the more steps you have to remember, the more likely you are to forget one of them and goof up.
So do you usually like multiply the whole equation by -1 and then add?
I do. You don't have to. You do it how you're going to do it. Once I get to this stage, though, y'all remember from probably back in algebra, you'd get here and then you'd quit and then you'd get part of it wrong. Go back and figure out what y is. I'm going to say that's 2.5 by 4 minus 5y is -25. So we got 10, which I will say -35 is -5y. 47. Okay? Yo.
Do we have to write it like the point like that, or can we just put x equals?
So long as you label them and I can find them, I'm okay. Just know that the actual solution is a coordinate, because you're saying if this line and this line were graphed, they would cross at the point 47. Same goes for the 3 variable systems, making a 3-dimensional coordinate. Okay, these were introduced in Algebra 2. This year we are switching it and we're moving them down to Algebra 1. Because Algebra 1, remember rational functions? Big honking quadratic over big honking quadratic? We're moving that out of Algebra 1 to Algebra 2, so we're kind of swapping things around. Because that's always the toughest chapter for kids in Algebra 1. They just don't do well with it. It's tough. And you get kids coming up to PreCalc or college algebra that haven't seen a rational function for 2.5, 3 years, and they have no idea what to do with it. So, yeah, freshmen are going to do this now. The idea behind a 3-variable system of equations is to do exactly what we just did. To solve a 2-variable system. That's my goal. But to do it, I need to eliminate a variable 2 different ways to get 2 equations that only have 2 variables. Then, once I know what those 2 variables are, I'll go back and solve for the eliminated variable. Okay, so at its heart, it's still just two variable system elimination. I just want to get rid of two variables first so that I can have a two variable system. So you look up here, look at your x, y, and z and say, which of those looks the easiest to get rid of either x or y or z two different ways? When I see a coefficient of 1 or -1, that's usually really easy to work with. So I could take this times a -2 and knock him out, times a -4 and knock him out. I could take 2x times a -2 and knock 4x out. So all fairly simple. I could just add equations 1 and 2 together to get rid of a z, take the top row by 5 and add it here to get rid of a 5z. They're all correct. In fact, if you remember how permutations work, there are at least 18 ways to start this problem. At least. It's more than that. 24? Yeah. A lot. So, consensus. Who says x goes away first? Who says z? Yeah. Okay. Get out of here, z. So the way that I always did these in Algebra 2 is I'd start by labeling so I know what the crap is going on. How many times have you been all the way to the end of your work? It's obviously wrong because you're getting just redonkulous fractions like 113 over 792. You know you're wrong. You go back and look at your work and it's just like a pencil vomited on your paper. You don't even know what to do. So you just start over. I don't want you to have to do that. So I always told kids to organize these. Write equation 1, x minus 2y plus z is 15, and equation 2, completely unaltered, 2x plus 3y minus z is 7. Combine those. Getting 3x plus y is -8. Or wait, those are both positive. Okay. My equal sign is kind of skewed there. 22. Okay, that's one way. Another way we said would be 5 times the top row. So I actually write that. I say 5 times equation 1. So it's 5x minus 10y plus 5z is 75. And equation 3. 4x, 10y minus 5z is -3. Magical Christmas land. Sometimes this happens. It's rare. Usually the problem is set up a certain way to make that happen. This doesn't always happen. Okay, so I'm going through the full process just so you understand that. In this case, yes, Magical Christmas land. I eliminated 2 variables. That doesn't always happen. What if there was still a y there? You would now have a equation with x and a y, an equation with an x and a y. You eliminated a variable 2 different ways. You now have a 2 variable system. Because Magical Christmas land happened, it's a really easy system. So you would take these 2 and say 3x plus y is 22, 9x equals 72 is your 2 variable system. Now, if you wanted to clean that up along the way, maybe you wanted to, along the way, say, divide by 9. So you have x is 8. It's still a 2 variable system, right? It's just one of the equations is x equals 8. Solve that 2 variable system the way that you know how, been doing for oh so long, and say 3 by 8 plus y is 22, that's 24, subtract it, y is -2. I eliminated a variable 2 ways, blue. I solved the two variable system, purple, orange. Now, go back and solve for the thing that you eliminated in the first place. We eliminated a z. So come back to any of the equations. I'm going to use the top one because it's got the smallest coefficients. And say x minus 2y plus z is 15. I now know that x is 8 and y is negative 2. Getting 8 plus 4 is 12. Subtract, z is 3. And at the very end of it, we can now say x, y, z is our three-dimensional coordinate. So this is the way that I had always set them up. Doesn't have to be the way that you set them up. But I have step 1, eliminate a variable two different ways. Step 2, solve your two-variable system. Step 3, solve for the thing you eliminated in the first place, and it becomes just a loop. I just do that every time. This is just how I see math. When I look at math, it pops out in like boxes and colors. You know, Iron Man style. That's just the way it looks to me. Doesn't have to be the way you do it. But if you saw that on a paper, is it organized enough that you can follow someone else's work? Okay. Anyone should be able to pick up your paper and understand what's going on. If you laugh at that thought, which as soon as I say it, there's usually two kids who are like, okay, you need to do better at your organizing, okay?
Have you books for you? Where do you want?
Desk?
Okay.
For this class?
For your Spartan time.
Spartan, okay. Okay, I'm gonna come back to this one. There, you know what? Yeah, I'll come back. Let's do some three variable stuff. I would like you to do, let's start baby steps. Let's go to number 27. Now, step 1 is always to eliminate a variable two different ways. Take a look at the third equation. Already missing a y. So what should I eliminate with the other two equations? I should probably get rid of y. Okay, go. Five gone, 3, 15, 1, 1, 5. 1, 1, 5, gone. So 5, 2, 10, x is 5. Is 0. So that's 5, 0. 5, 10, negative 2, 0. Did they switch the books yet? Okay. I did that with algebra books at a previous school. There was a couple of hicks that pulled their truck up to the door, and they were shoveling them in the back. They took like 400 or 500 math books with them. You know where that was going. Yeah, just this one for now. I want to make sure we at least got this. If you do finish it in good order and you feel good, I want you to back up to the one to the left of it, because that one is set up perfectly for substitution with three variable systems. I want to see if you can figure that one out. Duh.
Do you have to do substitution? The one before it?
For 23?
Yeah.
You don't have to, but boy, is it easier.
There's no reason.
Well, if you try to do it,
Okay.
I did.
And then, never mind.
Wait, did
I
you
figured
get
it out.
Did you use them for Zoom?
Yeah.
Uh,
X.
Just get executed.
It's fine.
It should work either way.
I just placed it. You sound like Tom Holland. Spider-Man.
I have been told I look like Tom Holland as well.
You sound like him. That's why it was bugging me for like 5 days.
No. Every time sometimes people like look at me and they're like,
Okay, please. Say, Mr. Stark, I don't feel so good.
I'm not saying that. I'm not saying that. I'm sorry.
I got an idea. You guys ever heard of this really old movie, Empire Strikes Back? This is awesome. All right. If I take equation 1, equation 2, I don't even have to monkey with them. It's just x minus y.
Oh my god.
2z.
I'm told I look like Tom Holland all the time. And then I
No, not like no, not even close. You sound like him.
No, I've had people tell me, you look like Tom Holland. I'm like,
Yeah, well, 50 pounds ago, I was told a fat white Vin Diesel, so people just have bad perception of what people look like. Okay. Okay. So if I've got x plus z is 5 by combining equations 1 and 2, but then directly above that we have a x minus z is 5, then 2x is 10, x is 5. If x is 5, then 5 plus z is 5. That means z is 0. Go back to one of the originals and say 2x plus y plus z is 8. I just found out z was 0. We know x is 5. So 10 away from 8, y is negative 2. Okay. I said the one next to it, was it 24, 3, is set up for substitution. Substitution says if x equals this junk, replace x with this junk. So if I come all the way down to the bottom here, I got r is this stuff. Could I replace r with this stuff? And r with this stuff? That would turn t into s plus 3s plus 1. Could I replace T with junk? That means I'll replace R with stuff that has S. I'll replace T with stuff that has S. I now have all S. So 5 of these minus 4 of these minus 3 of these is 3. R is 3s plus 1. T is 4s plus 1. Getting 15s plus 5 minus 4s minus 12s minus 3 is 3.
Because there was already
S plus 3s plus 1. I didn't write that part. I was getting lazy. Sorry. Combine like terms. 15 s's minus 4 s's minus 12 s's is a negative s. 5 minus 3 is 2. If s is negative 1, and I know t and r in terms of s, I can go back and find those. It's rare that you'll see one set up like this for substitution. Put a negative 1 in. Put a negative 1 in. And someone in here is bothered by that answer. It's so close to 1, 2, 3. Why isn't it just 1, 2, 3? Someone in here is bothered by that. It's not often that we get ones that are set up like this for substitution. It's just modeling a different way to solve the equations. So, substitution, the example we did was Magical Christmas Land. 27 was nice and easy because it was already kind of set up for you with a variable eliminated. I would like to see, can you do it when it's all scrambled up, start to finish? Okay. What's wrong with this? Right out the gate. Wrong order. So you go ahead and put it in the right order, then start working.
Are we gonna do 29?
I have no idea. We'll see how this goes.
I want to know how it's doing.
Yeah, if you're a big writer, I'm not. You can always do any problems and stuff on a separate sheet or in your notebook. Just next to that part in your notes, say scratch paper. And then maybe it's like 0.5 notes is just the page right after that in your homework. Just so it's following an order and I know where to look. Okay?
Question.
Yo.
Are we solving 40 substitution?
No, you do this however you're going to do it. Most kids are probably going to do that by elimination.
I would too.
Never did do attendance. Okay. We got Hannah. Taylor. All right, okay. I finally got it figured out. Taylor. Okay, there we go. I saw Holden, Paul, Lindsay, Britter, Rudy, Anna 1, Anna 2, Lars, Ella, Mariah, Claire, Grace, Natalie, Aubrey, Maddie, Colby. Cool.
Oh.
I suppose I should actually do this, right? Okay, I've never seen it continue doing it before. Well, normally, I ain't gonna do it again because it might spaz out like that. Normally, you make like a little dude, and you force choke him around the screen. No? Okay. Okay. Show hands who got rid of Z first. 3 of you? 4, 5? Okay. Who got rid of Y first? Normally you got like one kid who just takes the... He wants to go off-road. X? Okay. I saw more going with X, so that's what I'm going to do. Both are equally correct. First I'm going to do probably 2 and -3. So x minus 2y plus z is -5. Negative x plus 3y plus 2z is -7. Getting, come on now, y plus 3z is -12. All right. I'm guessing for those of you who got rid of x, probably did that and then used -2 times either one of these to get rid of equation 1. Just to show you, just to be facetious about it, y'all know that you can stack things too. Like, I could negate this whole row, negate this whole row, and add all 3 of them. It was about 3 years ago was the first time I saw a kid try that. But now, all x's are gone. 6, 9y. got 2 z's, 4 z's, 11, 18. That's a way to do it. Doesn't mean it has to be the way you do it. But I'm just showing you that is something you can do. And then maybe I'll take the top equation by -3 or -9. -9y minus 27z is 108. 9y, 4z is 18. Getting -23z is 126. Right?
No, that's what I was getting. I did not get that.
I never had that.
I got 6 equals 0, so that's why I got 3.
Did I do it dumb somewhere along the way?
I don't know.
Probably.
What is wait, on number 3 in the blue, wouldn't it be 7, not -7? If you multiplied it by -1?
Uh-huh.
Can you put
And then 11 plus 7 is 18?
No, in number 3 in the blue.
Oh, okay, okay. Negatives. The bane of math existence.
You made me think I messed up.
Good call. Okay.
I'm just on a roll today.
Get back over here. You go away. So we got y plus 3z is 2. A little bit better? Okay. I want to point out something, though. This is why I label equations. This is why I switch colors. Is it easier to define what step we're at? Okay? Mariah's able to say, like, something, something, 7, and I come over here like, no, blue. 7 on equation 3 in blue. Pretty easy to tell where we're going now. Okay, so that method of organization is there for that purpose. And then we'll go by -9, okay? -9y minus 27z, -18. There we go. And then if I bring that back, I get y equals 2. Go all the way back to the original. X minus 3y minus 2z. We said that's a 2, that's a 0. Okay? A simple negative. All right, now let's say I missed that. I ran it all the way to the end zone. Turns out it was the wrong end zone. Our football team. I get to the end of it and I got all these gross fractions. I know I'm wrong, but that's exactly where the error is. On a quiz, a test, daily quiz, 4 out of 5. You did the entire process right, and we can find exactly where the specific error is. You should not get 2, 3, 4 points off because of the domino effect. Okay? I really believe that. If you checked it, you know you're wrong. Come back in chapter 6 and I'll show you how to check it all on the calculator. Okay. Okay, now we'll back up 2 slides here. There we go. Y'all remember infinite solutions and no solutions with linear pairs or linear equations? You do all the work right and you get something that is either true or false. Just be aware that there is different vocabulary for it. Something that has a solution is called consistent. If it's a solution, it's consistent and independent. If it's infinitely many solutions, consistent and dependent. No solutions at all, inconsistent. It's just a different set of vocabulary that, depending on your teacher, you may or may not have heard. Why is this called infinitely many solutions instead of all real numbers? The slide right before that. It's not all the numbers. This line goes forever. There are an infinite number of solutions. But is that a solution? No. That's why I can't say all real numbers. I have to say infinitely many solutions. Okay? And then vocab. What kind of lines? Parallel lines. What's the line that perpendicular? Their slopes are going to be what? Yep, but the slope specifically, the numbers. Close. Let's say this one goes from here to here, goes down to 1, 2, 3, 4, 5. That's -2/5. It'll be a positive 5/2 to be perpendicular. It's called a negative reciprocal. Negative because I change a sign, reciprocal because I flip it. Okay, just wanted to do a quick review there. Down here with this example, if you just like put a big, okay, I get it, just so I know that we talked about it. Intersecting regions. Stay on the bench, dude. Y'all remember how to graph half planes? What do the inequalities do? You shade. Solid or dotted. Argue with your neighbor, both of them. Argue with your neighbor all the way back to chapter 6, algebra half. Get it. I want you to do these too. Figure it out. If you remember it, great. If you don't, smack your heads together and see if rust falls out.
Yeah, underneath that. Underneath that means it's a solid. There's not a solid.
Yeah, right over there, Lars?
Yeah, and then
Right? That smoke rolled back in yesterday. I'm back on that inhaler like 4 or 5 times a day. Stuff's nasty.
I thought it was fog when I woke up, so I prepared for cold.
where's it from? Montana, Wyoming, California. I don't know, somewhere over there. All of the West Coast. Yeah, I thought it was the West Coast. Well, it's up and then over. Oh, yeah, but there was a huge fire in Montana.
Yeah.
Hold on, I got you. I got you. My wife's a big news and weather nut, so here, remind to PreCalc. Photo library. That's why. Check your phone.
Oh, did you guys see it?
You guys will know when the time is ready.
Oh, you.
I thought we were done with this. I always forgot.
That's why.
There's one in South Dakota.
Yeah. There was one of these.
That little box between the interstate and Highway 34 out to Aladdin, there's been 4 in that little box just this summer.
All of Idaho.
Okay, what I'm seeing, seems like we remember this. 0.5 is 1/2. Y-intercept, down here. Up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. Put an auto tune, I'll make $1 million. Okay, solid or dotted? Okay. How do I know which way to shade though? Okay. 2 ways to do it. The way that most books are going to tell us is to actually pick a point and test whether it's true or not. If I put 0, 0 in there, I get 0 is greater than or equal to -3. Is that true? So 0, 0 being true means everything on that side is true. I'm not going to shade yet because I want to talk about that. Start at 7, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. You like reviewing the bare minimum of what you need to know to get in the class?
No, I just like this.
Oh, okay. Okay.
This is like the one section that.
Okay. Now, I can pick a point to put in and I can test it if it's true or false. Or this says y is it's less than or equal to the line. Yep. Down 2, right 1. Down 2, right 1, down 2, right 1, down 2, right 1. Okay. Okay. I want to talk about how you did this all the way back in that day. How many of you did the, you shaded that way for one, and then you shaded that way for the other, and then you just went and darkened the living crap out of that section? Who's that kid? Chaotic evil. Right there. Okay. The problem with that is in Algebra 2, we started talking about linear programming, where you would have 3, 4, 5, 6 of these on the same graph. It starts getting pretty messy. Who did the crosshatch thing? Lines going one way, lines going the other way, darken the waffle. Okay. Where the crosshatches would overlap. So those are ways to do them, but the way that I've always taught my kids so that we didn't have such a messy paper is I would say I'm shading down from this one and I'm shading up from this one. I can see where all the arrows are pointing. They're pointing to that quadrant. So that's the one that I'm going to shade. I need to be able to tell where your answer is. That's it. Okay. So, and then the one below that, if I got parallel lines, what is it? 4 and -8. So 4, -8, what was it? 2x or 3x? 3x, right? Dotted, right? Okay. What happens when they shade like this? No solution because there's nowhere that they overlap. What happens when they, I think this one was the opposite. Was it like this? You'd shade everything in between, right? what happens if it's like this? Everything to the left of the left line, because that's where they're both true. So I just want to make sure that we're okay with that. We remember it. We can do it with multiple graphs. Okay. Right? It's just three things. "12 minutes. I've never not gotten through this, though.
I think we went over it like a day.
Okay.
We never.
Y'all, your assignment is going to be from 05. I don't know what we're going to get done here. We only got like 12 minutes. Just try to do what I can. Okay. Matrices you first saw in Algebra 1. You should have used them for transformations in geometry. A matrix is just a way to organize data. That's it. It is a row by column arrangement of data. That's why you'll often see a table that becomes a matrix, because it's got rows and columns. An element is any one data sub row column that is an element of the matrix. A sub RC, row column. Here's what I mean. This element right here, see how it's in the second row, first column? In matrix A. I would call it element A sub 21. A subscript denotes which one. It's not a mathematical operator. If it's a superscript, well, that's an exponent. That's a mathematical operator. A subscript just tells you which one. So if I see element A sub 21, it tells me the element, because it's lowercase now, of matrix A in the second row, first column. A sub RC, row column. Okay. Then yeah. It'd be big. So what's this one? Third row, second column. A sub 32. Okay, it's just a way to organize and label data. The more data you have, the more important a method of organization is to it. Case in point, 2-variable system versus 3-variable system. If you don't have a method of organization, how many of you had your 3-variable systems in Algebra 2 took up an entire page and it was just chicken scratch? It was just random letters and numbers floating all over, and at the end, hopefully you got an answer. Okay? So, a little bit more vocabulary. Row and column matrices, naturally, are ones that only have one row or one column. Square matrix, row by column, is going to be the same dimensions. So 2 by 2, 3 by 3, 4 by 4. Those are going to be really important when you get to inverses, Kramer's rule, that kind of stuff. I don't know if we'll have time for it this year. It's usually one of the lessons that gets cut out because Mr. Spear said he doesn't need it for calc. Zero matrix, if you can't figure that out one, sorry. So, figure those two out. If you know the definitions, what's what?
A and B.
Yeah, what are the dimensions, row by column? What is element A sub 13? And whenever I see that, I always remember. Anyone else here live in Disney Hell? A113? No?
No, I know exactly what you're talking about. The first time I ever noticed it was in wall.
Yep.
I have A and B done. Are we just supposed to do A and B?
A113 is a particular classroom at, I want to say it's University of California. And a lot, and not just Pixar. It's a particular classroom. It's where they do the visual arts classes at, I think it's University of California. And a lot of the people who work at Disney Pixar, they all went there for their classes. That's where they spent most of their college career. So they try to sneak A113 into as many movies as they can. It's Andy's mom's license plate on her car. It's the order that tells Wally's ship not to go back to Earth. It's in all kinds of places. All right, this should be a 2x3. A sub 1, 3 is the first row, third column. Okay? So that's just getting the terminology out of the way. Adding and subtracting matrices. The only way that you can add and subtract matrices is if they have the same dimensions, because you're trying to compare similar elements. If I say A plus B, 2x2 plus 2x2, we're good. You just add the corresponding elements. A plus 12, 3 plus negative 7, negative 5 plus 6, 14 plus negative 23. Okay? But if I try to do matrix B minus matrix C, do you see why it doesn't work? There's no element there to even subtract. So you would just say no solution does not exist. Okay. Scalar products. It is literally distributed into the entire matrix. Yes. You should have used these in geometry to do dilations. I think for the whole lot of you, that was probably shut down. Or first semester last year when 1 in 6 students was out of the building at any one time. Okay. Right? Scalar multiplication, you just multiply by the scale. Okay, you do B. Show me that you understand basic arithmetic. Okay. Cool? Okay. All right. Instead of doing the equations, I'm just really quick going to remind you why you should have known this. Y'all remember okay. This is why you're supposed to know how matrices work. This is why you did basic operations in Algebra 1. If you have triangle ABC and I say I want you to translate it 4 units down, translate it 2 units left, reflect over the y-axis, dilate by a factor of 3. To do 4 operations to it, that would have taken you your entire paper, right? Probably 10 minutes. What if I said triangle ABC is row column. Okay. X then Y. Organization. Okay. So if I say I want you to translate 4 units down and 2 units to the right. Five, 0, 2, 1, negative 5, 4. That's 2 transformations knocked out already. I want you to reflect over the y-axis. Cool. Negate all your x's. I want you to dilate it by a factor of 3. I just saved you 10 minutes and a piece of paper. This is how you're supposed to do transformations in geometry. So, if y'all ever want to do some geometry review before an ACT, hit me up. I got a monkey with the assignment. Next hour is my prep anyway. I'll send it out then.